And welcome to my science class, grade 10 students from section Cat's Eye, Obsidian and Peacock Ore of Santa Ana National High School. I am your grade 10 science teacher, Emor Forones Alvar. Today, we will be discussing our new topic for this week, which is plate boundaries of Module 2. Kindly get your notes and write the important terms that will be discussed. In your previous lesson, you were done with the plate tectonics and its relationship for the distribution of earthquake epicenters, active volcanoes, and major mountain belts. Plate tectonics is a theory that explains the surface of the earth is broken into large and small lithospheric plates which are moving slowly. The size and position of these plates change as years pass by. They move against each other at their edges, causing intense geologic activities such as earthquakes, volcano, and mountain building. This Module 2 will provide you with information and activities that will help you understand plate boundaries, which are divergent, convergent, and transform fault. After going through the Module 2, you are expected to first, describe the different types of plate boundaries. Second, identify the places or plates that lie on the different types of boundaries. So, what are we waiting for? Let's start! Look at the three pictures. Can you cite what are their differences? Yes, you are right. They are moving in different directions. Now, do you have any idea what type of movement is that? So, that will be our discussion in this video presentation.
And so, let's start. Our topic in this presentation is types of plate boundaries. Studying plate boundaries is important because along these boundaries, the formation of the lithosphere is happening. These geologic events have a great impact not only on the environment but also on us. There are three distinct types of plate boundaries which are differentiated by the type of movement they exhibit, namely divergent plate boundary, convergent plate boundary, and transform fault boundary. The first type of plate boundary is termed divergent boundary, wherein plates move apart, creating a tension zone. Divergent plate boundary is also known as constructive form of plate boundary. A divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, earthquakes are common and magma, a molten rock, rises from the Earth's mantle to the surface, solidifying to create new oceanic crust. In plate tectonics, a divergent boundary or divergent plate boundary is a linear feature that exists between two tectonic plates that are moving away from each other. Divergent boundaries within continents initially produce rifts, which eventually become rift valleys. Formation of rift valleys and oceanic ridges are indications that the crust is spreading or splitting apart. In this case, the plates are forming divergent plate boundaries wherein they tend to move apart. Most divergent boundaries are situated along underwater mountain ranges called oceanic ridges. As the plates separate, new material from the mantle goes up to fill the gap. These materials will slowly cool to produce new ocean floor. An example of a divergent boundary is the Mid-Atlantic Ridge. It is a mid-ocean ridge. a divergent plate boundary located along the floor of the Atlantic Ocean. There are also mid-ocean ridges at Indian Oceans and Pacific Oceans as well. Divergent boundaries also create rift valleys and new oceans. The Rift Valley in East Africa is the result of a divergent boundary. The spreading rate of these ridges may vary from 2 to 20 centimeters per year. Although a very slow process, divergence of plates ensures a continuous supply of new materials from the mantle. The Mid-Atlantic Ocean Ridge is an example of spreading center which causes the divergence of the South American plate and the African plate. Now, we will proceed to the types of divergent boundaries. There are two types of divergent plate boundaries. First is oceanic divergent boundaries and the other one is continental divergent boundaries. Let us have the oceanic divergent boundaries first. When a divergent boundary occurs beneath oceanic lithosphere, the rising convection current below lifts the lithosphere, producing a mid-ocean ridge. Extensional forces stretch the lithosphere and produce a deep fissure. When the fissure opens, pressure is reduced on the superheated mantle material below. It responds by melting, and the new magma flows into the fissure. The magma then solidifies and the process repeats itself. The ridge is a high area compared to the surrounding seafloor because of the lift from the convection current below. Effects that are found at a divergent boundary between oceanic plates include a submarine mountain range such as the Mid-Atlantic Ridge, volcanic activity in the form of fissure eruptions, shallow earthquake activity, creation of new seafloor, and a widening ocean basin. Mid-oceanic ridge is a formation from the diverging of oceanic plates. The Mid-Atlantic Ridge is a classic example of oceanic divergent boundary. Now let us proceed to continental diverging of plates. When a divergent boundary occurs beneath a thick continental plate not vigorous enough to create a clean, single break through the thick plate material. Here, the thick continental plate is arced upwards from the convection current's lift, pulled thin by extensional forces, and fractured into a rift-shaped structure. As the two plates pull apart, normal faults develop on both sides of the rift and the central block slide downwards. Earthquakes occur as a result of this fracturing and movement. Early in the rift-forming process, streams and rivers will flow into the sinking rift valley to form a long linear lake. As the rift grows deeper, it might drop below sea level, allowing ocean waters to flow in. This will produce a narrow, shallow sea within the rift. This rift can then grow deeper and wider. If rifting continues, a new ocean basin could be produced. Volcanic activity sometimes occurs within the rift. Rift Valley is the formation from the diverging of continental plates. The East Africa Rift Valley is an example of this type of plate boundary. There, the plates have fully separated and the central rift valley has dropped below sea level. Effects that are found at this type of plate boundary include a rift valley sometimes occupied by long linear lakes or a shallow arm of the ocean, numerous normal faults bounding a central rift valley, shallow earthquake activity along the normal faults, volcanic activity sometimes occurs within the rift. After learning the effects of divergent plate boundaries on the Earth's lithosphere, it's time for us to move on to a certain activity entitled Going Separate Ways. Objectives of the activity are: explain the processes that occur along divergent boundaries, determine the results of plates that are moving apart. Materials are photographs of rift valleys and oceanic ridges. Procedure: first, analyze the photographs of rift valleys and oceanic ridges from the previous slide and answer the questions that follow. First, what are common in the four pictures? Next, millions of years ago, the land masses in each picture were once connected. What do you think is happening to the Earth's crust in those pictures? And the third one, if this event continues for millions of years, what do you think will be the effect on the crust? And for the last activity, complete the drawing by illustrating your answer from question number 3. Previously, we had discussed the first type of boundary, which is the divergent plate boundary. Now, in this video presentation, we will be discussing the next type of boundary, which is the convergent plate boundary. So, sit back and relax while watching and listening my discussion. Convergent plate boundary. Convergent plate boundaries are locations where lithospheric plates are moving towards one another. A convergent boundary, also known as a destructive boundary, is an area on Earth where two or more lithospheric plates collide. One plate eventually slides beneath the other, causing a process known as subduction. The subduction zone can be defined by a plane where many earthquakes occur. Subduction zones are areas where one lithospheric plate slides beneath another at a convergent boundary due to the lithospheric density differences. Subduction zones are often marked by an abundance of earthquakes, the result of internal deformation of the plate, convergence with the opposing plate, and bending at the oceanic trench. These collisions can lead to volcanism, earthquakes, destruction of lithosphere, and deformation of the crust. The geologic features related to convergent boundaries vary depending on crust type. There are three types of convergent boundaries: oceanic and continental convergence, oceanic and oceanic convergence, and continental and continental convergence. Let's start with oceanic and continental convergence. This convergence happens during collision of two plates. One has continental edge while the other has an oceanic edge. When continental and oceanic plates collide, the thinner and denser oceanic plate is overridden by the thicker and less dense continental plate. The oceanic plate is forced down into the mantle in a process known as subduction. From the diagram, the denser oceanic plate, or the plate A, undergoes what we call subduction process. or the bending of the crust towards the mantle. Since the mantle is hotter than the crust, the tendency is the subducted crust melt, forming magma. Addition of volatile materials such as water will cause the magma to become less dense, hence allowing it to rise and reach the crust once again and causing volcanic activities on the continental leading plate. For the oceanic crust, one important geologic feature formed is the trench, also called submarine valleys. Ocean trenches are the deepest part of the ocean. One of the deepest is the Philippine Trench. This event also gives rise to the formation of a volcanic arc near the edge of a continental leading plate. The next type of convergence is oceanic and oceanic convergence. When a convergent boundary occurs between two oceanic plates, one of those plates will subduct beneath the other. Normally, the older plate will subduct because of its higher density. The leading edge of the subducted plate will eventually reach the mantle, causing it to melt and turn into magma. The molten material will rise to the surface, creating a volcanic island arc parallel to the trench. Volcanic island arc is a chain of volcanoes positioned in an arc shape as seen in figure. Like the first type of convergent boundaries discussed earlier, converging oceanic plates will cause formation of trenches, and these trenches will become sources of earthquakes. Underwater earthquakes, especially the stronger ones, can generate tsunamis, the Japanese term for harbor wave. Tsunami is a series of ocean waves with a very long wavelengths. The third type of convergence is continental and continental convergence. When two continental plates converge, a collision zone is formed. Unlike the other two types of convergent boundaries, there is no subduction for this particular type of convergence. No trench, no volcano, and definitely no island arc are created during this process. Instead, what is created is a large group of tall mountains called mountain range. In this type of convergent boundary, a powerful collision occurs. The two thick continental plates collide and both of them have a density that is much lower than the mantle, which prevents subduction. The intense compression can also cause extensive folding and faulting of rocks within the two colliding plates. This deformation can extend hundreds of miles into the plate interior. The Himalaya mountain range is the best active example of this type of plate boundary. About 40 to 50 million years ago, two large land masses, India and Eurasia, collided to begin the formation of the most visible product of plate tectonics, the Himalayas. Since subduction is impossible between two colliding continental plates, pressure is released by pushing the crust upward and forming the Himalayan peaks. Effects found at a convergent boundary between continental plates include intense folding and faulting, a broad folded mountain range, shallow earthquake activity, shortening and thickening of the plates within the collision zone. After learning the different types of convergent boundaries, let us now explore the various effects of these collisions on Earth's lithosphere. Let us answer the activity that follows to determine how far you understand the topic convergence of boundaries, which are oceanic and continental convergence, oceanic and oceanic convergence, and the third type is continental and continental convergence. So now, kindly perform the activity of convergent boundary. Good luck! From our previous discussions, you've learned the different types of plate boundaries, which are the divergent and convergent boundary. Now, we will be discussing the third type of plate boundary. In grade 8, you were introduced to different types of faults such as normal, reverse, and strike-slip faults. You also learned that faults are fractures in the Earth's crust created by different types of forces acting on the lithosphere. There is one type of plate boundary that resembles the strike-slip fault. Though much larger, transform fault boundary is similar to strike-slip fault in terms of the relative motion of adjacent slabs of rock. To find out more about this kind of plate boundary, this presentation will let you understand the event that could happen out of this boundary. Transform fault boundary. Transform plate boundaries are locations where two plates slide past one another. The fracture zone that forms a transform plate boundary is known as a transform fault. Most transform faults are found in the ocean basin in connect offsets in the mid-ocean ridges. A smaller number connect mid-ocean ridges and subduction zones. Transform fault boundaries are also known as conservative plate boundaries because they involve no addition or loss of lithosphere at the Earth's surface. A transform fault or transform boundary is a fault along a plate boundary where the motion is predominantly horizontal. It ends abruptly where it connects to another plate boundary, either another transform or spreading ridge or a subduction zone. Although most transform faults are located within the ocean basins, there are few that cut through the continental crust. An example of this is the San Andreas Fault. The immediate concerns about transform fault boundaries are earthquake activities triggered by movements along the fault system. Most such faults are found in oceanic crust where they accommodate the lateral offset between segments of divergent boundaries forming a zigzag pattern. A smaller number of such faults are found on land, although these are generally better known as the San Andreas Fault. A transform fault is a special case of a strike-slip fault that also forms a plate boundary. Don't you know that a strike-slip fault is not a transform fault? Transform faults can be distinguished from the typical strike-slip faults because the sense of movement is in the opposite direction, as what you've seen in the illustration. A strike-slip fault is a simple offset. However, a transform fault is formed between two different plates, each moving away from the spreading center of a divergent plate boundary. When you look at the transform fault diagram, imagine the double line as a divergent plate boundary and visualize which way the diverging plates would be moving. A smaller number of transform faults cut continental lithosphere. The most famous example of this is again the San Andreas Fault Zone of western North America. The San Andreas connects a divergent boundary in the Gulf of California with the Cascadia Subduction Zone. Another example of a transform boundary on land is the Alpine Fault of New Zealand. It was stated at the beginning of this module that majority of tectonic activities like earthquakes, mountain formations, and volcanic activities happen along or near plate boundaries. But there are some cases wherein activities take place in the middle of a plate. Let's take the case of the Hawaiian Islands. Here, we can find some of the largest and most active volcanoes of the world. If we're going to look at Hawaii, it is situated right in the middle of Pacific Plate and not along the boundaries. And finally, we're done with our topic, which is the different types of plate boundaries, namely convergent boundary, divergent boundary, and transform fault boundary.
And we're done with our video discussion of Module 2, Plate Boundaries. Kindly write your answers in a piece of paper, then take a picture on it if you are through and kindly send it in Messenger or drop your answers in grade 10 drop box at Guerrero campus. If you encounter any difficulty from the topic of Module 2, do not hesitate to consult me as your science teacher. I hope that through this video discussion, you will experience easy, meaningful learning and gain deep understanding about the topic. For more science educational videos, just visit my YouTube channel, Science Time Discussion. All topics starting from Module 1 will be uploaded there. You can do it! Always bear in mind that you are not alone. See you next discussion. Again, I am your grade 10 science teacher, Emor Forones Alvar. Keep safe. Have a blessed day, students.